very happy to be back here, so thank you so much for inviting me. And this is a picture here of myself and Christopher Gagem, who's in the same cohort as I was, arriving at Michelle's house, Michelle Larson, for a late October Halloween party in 1999, which is the last time I was here. Can't believe it went so long. I'm a big fan of Hickory Hill Park, which Michelle's house is near. And this is shortly after I'd spent the entire afternoon just kind of wandering through the park and kind of emerged out of the woods, and there was Chris Gagem waiting for me right there, just as Chris arrived for the party. So, and yeah, Chris and I were physics lab partners in high school, by the way. I don't know how many of you knew that. And we totally went our separate ways in college, and you know, we really only knew each other in the physics lab. And he was an amazing physics lab partner, as you might imagine. Those of you that have had him in class, he's very meticulous and efficient and calm about everything. And we just showed up, happened to show up in, I remember it was John Pryor's regression class when I thought, hey, that guy looks familiar. And he thought, oh, that guy looks familiar. And afterwards, we had the joyous reunion and realized who we were. And that was a lot of fun. And I think my favorite memory of Chris while we were here at Iowa is when Tom Brokaw gave a talk. It was just down the hall, actually, here at the Union. And afterwards, as he was on his way out, he was shaking some people's hands and everything, and Chris and I were sort of shuffling to see if we could get a chance to meet him. And I guess it was kind of hot and stuffy because everyone was pretty crowded. Chris took off his coat, and all of a sudden, like a million quarters and nickels and dimes go flying everywhere. He must have a ton of change in there. And everyone within like a 10-foot radius dropped down to help him pick up his change. And of course, I was the greedy guy who walked over everybody who was helping Chris out and shook Tom Brokaw's hand. And felt terrible about it. But Chris was so amazing that afterwards, he was doing nothing but rejoicing for me. He was just so happy that I got to meet Tom Brokaw. Never mind that he didn't get to meet Tom Brokaw. But that's just the kind of guy Chris was. So, and I have a story about Dr. Tim Robertson too, before I start talking about a little bit about SAS. So I think one of my favorite Iowa memories was when I saw Tammy Siegel, the department secretary, running down the hall saying, John, you got to come here right away. Dr. Robertson has a problem with his computer. I think he's been hacked. And at that time, I was what was called the computer RA. I don't know if you still have that position or not, but it's sort of a position when the department went over from Unix to Windows machines. I was the person they, for some reason, trusted to help that transition happen. And so I was that instead of a TA that semester. Yeah, so I went down quickly to Dr. Robertson's office. Said, hey, what's going on? I heard, possible hacking incident here. And he said, yeah, my computer's telling me that somebody at the university is accessing my grade spreadsheet where I'm keeping track of my grades. I said, okay, show me what happened. And he duplicated the activity of opening his grade spreadsheet. And it turns out it was just already open. And so it was simply telling him, you already have this spreadsheet open. but in Microsoft terms, which is a little different. So his name was entered in the computer as the University of Iowa instead of Tim Robertson. And so that was the whole dilemma that he was so worried about. And I tried to explain it to him, and he just didn't believe me. So I guess this is another story I'm a little guilty about. The way I resolved this one was I opened up a text editor, looked really serious, and started typing some things in and gazing intently at the screen, and then told him, okay, I've just verified that you were not hacked. I don't know if I ever confessed that to any of you. And then all was well again. So I'll just talk a little bit about SAS here, not too much. So I'm a statistical software developer there, and for those of you who use it, I'm working on proc power and proc GLN power, which are powering sample size for different kinds of models, and also getting in a little bit with non-inferiority and equivalence testing. So I was very happy to see Mark Rothman's recent book on that. And there are 5 different flavors of statisticians at SAS. I don't know if you knew that, but there are actually 2 different kinds of developers as well. They have a whole division that works on sort of industry-specific solutions, and will concentrate on, for example, like clinical trials or genomics or statistics in marketing, like marketing optimization, things like that. They're also testers, thank goodness. So otherwise, my code would get out in the wild way too soon. And the testers are really pretty amazing there, and I think that's what helps SAS get its reputation for high-quality software, is because they have so many testers. I think almost as many testers as developers, really trying to break our code all the time. There's also tech support staff who are also amazing. And on the next slide, I have a little bit more about them. And I also have some people who teach training courses. And all these people have degrees in statistics. So I always thought of a job at SAS as just involving programming the software, but there are lots of different flavors of work that a statistician can do in SAS. And so in tech support in particular, here's a pretty awesome statistic that we get on average about 10,000 inquiries that end up at statisticians in tech support per year, which if you do the math on that is about 40 a day. So don't feel bad if you have a question about SAS and want to call in and talk to a statistician, because they love doing it. It happens about 40 times a day. And a lot of those calls are answered within 1 minute, which I think is a little bit better in tech support than an average company. So I don't know, I guess I could help do a little bit of bragging for SAS while I was here. So I could tell them I spoke highly of them. Okay, so switching gears here a little bit. So I've been practicing Buddhism for about 12 or 13 years or so, and it actually all started here. And I remember very specifically when Tammy Siegel gave me the book called Siddhartha for my birthday. And I remember reading that book. It really sparked my interest and sort of helped me realize, wow, this is something I really want to look into later. And over the years, I've noticed a lot of interesting parallels between Buddhist psychology and philosophy and all the stuff I learned here about statistics. So I just thought I'd share a few of those with you. So here's sort of just a little matrix here comparing the two. So on the left hand, under the task column, I try to summarize all of Buddhism into these 4 types of things. Like you spend some time learning, spend some time contemplating what you've learned, and then really try to figure out a take-home message, concentrate in on what's the real point here, and then you have an action plan of what to do with it. And in statistics, I think how that plays out is that your learning process is, of course, taking courses and getting teachings, which I did here, and sort of in a level more like helping a client. The main focus of your learning would be the research question. Exactly what is the question, and what is the goal of the person you're trying to help with statistics here. And if you're really lucky, you'll be doing this before the study actually occurs, and you'll be able to talk about the planning of the study. And I actually looked up a quote by Ron Fisher, which I liked, about when study planning doesn't happen. So R.A. Fisher in, looks like the 1960s, said, to consult the statistician after an experiment is finished is often merely to ask him to conduct a post-mortem examination. He can perhaps say what the experiment died of. So of course, as a developer of common sample size software, I also love to remind you that you really should do your statistics starting a study plan. And of course, you learn about the theory and the methods, and answer the questions. So that's all the learning process that I see sort of in statistics. And Buddhism is kind of very similar. You attend some teachings, hear about the historical recorded teachings, and think about your motivation, which is sort of like looking at the research question. And I think the motivation of Buddhism is sort of that, just in general, to get happy and help others do the same. And instead of learning theorems and formulas and distributions and things like that, you just learn different tools to work with your mind. So, all right, so once you're done learning, then you do the contemplating part, which in statistics I think of as sort of like trying out a set of data, looking at it and see how well it fits your hypothesis that was part of your research question. And I think the analog in Buddhism is you look at your experience and see whether that models the teachings that you've been listening to. So I think they're both very similar processes. Checking empirical observation against an assumption. And then once you've gone through that process, you can sort of try to get the essence of the result, which in statistics is to summarize things with summary statistics, depending on which camp you're in, maybe p-values, whatever the case may be. And in Buddhism, it's very similar to that. The idea is to sort of meditate on the possible correspondence between experience and teachings, and then when something resonates, you focus on that. You just sort of focus on the sensation of that discovery. And in both cases, I think it is sort of a narrowing down to the fine essence of the discovery. And the last part being the action plan in statistics, what do you do with the end result? What was the reason you did it in the first place? If you're more in the realm of academia, that would be publishing and enhancing the body of knowledge, basically making the march of science continue. March of science is a phrase that a colleague of mine uses that I like. If you're more in the realm of policy, you can help make decisions and change policies based on the outcomes of your studies, of course. So I think this is how I see sort of the role of statisticians, is deploying your study results to the world. And in Buddhism, as I mentioned before, it's sort of about getting happy, overcoming all the suffering, and helping others. So, which I believe statistics does as well. So perfect correspondence there. Okay, so what prevents all this from happening smoothly? My favorite word for that is delusions. So delusions in Buddhism is really just sort of a phrase for seeing things inaccurately, like seeing an incorrect version of reality, which Buddhism believes really to be the source of all of our troubles. We track it to the ultimate source. And just some 4 examples of delusions here that I think are major ones is taking things to extremes. Like the 2 extremes talked about in Buddhism is believing that the self just doesn't exist at all, and believing that the self is self-contained somewhat. That's sort of represented by nihilism and eternalism. And you probably heard the term middle way. And that's sort of the idea there, is to sort of get in the center and avoid those 2 absorption states at either end. And I think the analog that I see in statistics to that is trying to estimate a proportion with a binary estimator. Like all you ever get is 0 or 1. That's not going to be a very good estimator. And bad definitions. So I love statistics in that it's very serious about its definitions. And I think that's a big problem. Well, probably trying to study anything. But in Buddhism, I notice a lot of misunderstanding about words, especially like attachment and happiness. Like people argue about, is attachment bad according to Buddhism? And well, it totally depends on the definition, of course. And people often go home from this conversation sort of depressed, like, oh man, if I want to be a good Buddhist, I can't fall in love and, really feel close to my kids and all that. So it's just a matter of definition. And sort of a cheesy phrase I like to use for statistics from the real estate world about location, 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 notation, notation, notation. And that's one of the things that's been very helpful in my job at SAS, I think, is because a large part of my job is taking research papers, trying to convert that into a workable algorithm. And I often use notation that's completely different than I'm used to, but at least it's consistent. So I really relied on the practice that I got here, really focusing on notation and having that sort of be the first stage in approaching any problem, is getting your terms straight and what does each usually Greek letter mean. So another delusion is suffering, which another common misconception in Buddhism, I think, is that it's, you Buddhists always think about suffering, so obsessed with suffering. And I think that's another definition problem too, because suffering has lots of different aspects. And my favorite type of suffering to consider, mostly because I practice it a lot, is laziness. And I find it very interesting that in Buddhism they talk about 3 different types of laziness. The first is just sort of the gross kind, like, I just don't want to do that. I can't be bothered. The second kind is procrastination, which I really don't know much about. But I hear it's when you sort of do want to do something, but you end up putting it off because you think it requires effort and you're not as attached to it as other things. I often find that the third type of laziness the most interesting, which is the thought, I can't do that. Which Buddhist teachings challenge you to look closely at that and say that a lot more than you think. You'll probably look closely and see that you really do believe you can do it, but you're sort of fooling yourself and getting yourself out of it by pretending that you aren't capable of it anyway. So they actually see that as something like, no, that's not an excuse, that's laziness. And when I thought about that, I thought of the different types of estimators you can talk about in statistics, like the blue estimator, the best linear unbiased. And I guess it's kind of weird to talk about that with suffering, because blue and suffering don't go together here. So if it's blue, you're not suffering, you have a great statistic. And of course, best meaning that it has the smallest variance, linear in the data, and U being unbiased. So those are the ways to not suffer when you get a good statistic. And of course, bad habits are a problem in both Buddhism and statistics. And in Buddhism, they talk about a lot in terms of are problems coming from misaligning causes and effects. Like we make habits of associating A and B together when they really have no correlation at all. And I think one of the most interesting examples, it's a little bit controversial, is a lot of people ask in Buddhist teachings, like, how do you explain serial killers? Like, obviously killing makes them happy, so doesn't that totally disprove, all your teachings in Buddhism about pacifism and all those things? And the explanation for that is that at least looking at it from a perspective of karma, the killing itself doesn't lead to the pleasure of the killing in that case, that actually the cause of the pleasure is actually, helping others in the past. And there's this weird system that they explain in karma where it just happens to be correlated with the killing. And it's actually not a cause at all. Very, very, very much like the distinction between correlation and causation in statistics. And as you know, that's often misused to imply that a study is important when it's really just sort of an example of a spurious correlation. So let's see. I just thought of one thing back here in the motivation part. That reminds me of another memory from Iowa where I don't know if the Daily Iowan still does this, but they used to ask sort of a question of the day to 3 students that they found walking by in the street. And I was flagged down for a question of, so what did you, no, it was worded as, so what would it take for you to leave an artistic performance? And I thought about that. I was like, well, that's a pretty liberal point of view on that. Like, I really believe in artistic expression. So I said, well, probably a fire. So I was sort of trying to be smart about it. Well, it turns out the reason they asked the question is because the night before was when Norm Macdonald was the guest speaker at I think it was the athletic department's family picnic or family event, and apparently launched into a lot of really distasteful jokes and topics and stuff that they really didn't think were good for children. There were a lot of children there. So I was published the next day as being all snarky about, well, I would never leave an artistic performance. Whereas the other 2 people made very meaningful comments about, oh, like, I really wanted to give him a chance, but it was all about Norm Macdonald, and I was totally clueless. So that was a clear case of just not knowing what the motivation of this question was. Let's see. So let's move on here to, I just wanted to mention briefly sort of the different flavors of statistics there. The content I practice is Tibetan Buddhism on the left there. And I think there's a wonderful statistics to it that I think summarizes the Tibetan approach very well. I don't know if you know George Box had more than one quote, but he did say something about Doug Wolf having the best seminar that particular year. But in addition to saying that, all models are wrong, but some are useful. And that picture sort of representative of the style of Tibetan Buddhism. It's very ornate, a lot of concepts, very busy and elaborate. And this particular concept is sort of illustrating the idea of helping others, and that figure in the center is a guy with 1,000 arms, with the idea being that having 1,000 arms to help 1,000 different people at the same time. And I think my personal motivation for that is, again, Tammy Siegel. And I always think of Tammy as having all these arms, helping everybody at once, saving us when we miss deadlines and so forth. And you might be a little bit more familiar with Zen. And I found a quote by Ari Fisher that I think represents Zen pretty well. Fairly large print is a real antidote to stiff reading. I think another way of saying less is more. And Zen sort of takes a different approach to really simplifying and have sort of the intuition come from the focusing. Okay. So if you're curious about the word statistics itself, speaking of like notation and definitions, I actually had no clue what the word meant, didn't even really think about it until I ended up reading a book called Damned Lies and Statistics, which is a very interesting book. And so it turns out that in 17th century Europe, there was an effort to count the births and marriages as sort of a way of indicating the health of the state, how well it was expanding. And the people who did this were called statists. And then the science of doing that ended up being called statistics. And of course, people who do it are statisticians. So it's interesting how the word just started out with state. And I suppose you could call yourself statist just to be simple. So we had to add an IC on the end and then add an IAN on the end of that, so it really means the same thing. So, and we talked about delusions earlier. Here's one of my favorites. And here's a statement that I found in a recent text here. about p-values. So p-values is an interesting topic of mine as well. So if we're willing to start a difference when p is less than 0.05, the usual threshold, he says we're tacitly agreeing to accept the fact that over the long run, we expect one assertion of a difference out of 20 assertions to be wrong. And if you look closely at that, that's just a misunderstanding of the definition of a p-value. But I think the question that's asked in that paragraph is a really good one. And I worked with a colleague, Ralph O'Brien. Some of you might know him. He was a biostatistician at the Cleveland Clinic for many years. And he likes to call what Glantz is getting at in this statement a crucial error rate, because it's really what we want to know that we don't. And so basically all it is reversing the conditional probability in the definition of the two different error types. So the errors are defined in the probability of significant or insignificant p, depending on whether the hypothesis is true or not. But what you really want to know for practical purposes is to know the probability that you're correct if you think that the study was significant or not. And so I'll just skip right on over to something you may have seen before, called Bayes' theorem. So as you know, it's the handiest way to switch conditional probabilities around, and that's exactly what's done in this case to get these things called crucial error rates. So, and the catch, there's always a catch of course, is they need to be a little Bayesian. So if you can start out with a prior guess of what the probability is, that the study is meaningful, that there's some sort of effect that you're looking for, then you can turn that through Bayes' theorem to get the probability that your inference was correct, whether you rejected the hypothesis or not. So I really find that interesting, and I think it's possible to sort of integrate that into this march of science concept by you can sort of have a measure for the probability of an effect, maybe based on an initial study, and improve on that number, or maybe make it worse depending on the outcome of the study. You can update that number and keep on updating with future studies, and look at that instead of the p-value. That's sort of your measurement, since it really is estimating a probability here. So that's about it, and thank you very much again for inviting me.